Alright, so today we are going to talk about multi-step inequalities. So really we've kind of talked about the new big things that are different as far as inequalities and equations go. So we already know how to solve multi-step equations. We already know what's different about inequalities and equations. So honestly guys, I think today, although the inequalities may be tougher, one, we don't have to graph today, just because we did a lot of practice with graphing yesterday, so we're not going to worry about graphing today. But also, I think these are sometimes a little bit easier to solve than those one-step inequalities. Sometimes. So, solving multi-step inequalities, okay, should be the same steps as solving multi-step equations, okay? We're going to distribute, and remember, as with equations, sometimes all of these steps aren't necessary. Sometimes there's nothing to distribute. Sometimes there's no like terms to put together. Sometimes the variables are already on the same side, but if you can do any of those things, you want to do those first, then you're going to solve the inequality. But the big thing, since they're inequalities, not equations, remember you have to flip the sign if you multiply or divide both sides by a negative number. Now, kind of like with equations, most of the time when you solve an equation, you get an answer. X equals 5, X equals 6, X, whatever it is, you get an answer, okay? But sometimes you got these different answers. Remember, you got no solution for all real numbers? That can happen with inequalities as well, but it looks a little different because it's inequalities. So let's go through each one of those types of answers and see what these will look like. Okay, so first one, if we have a normal answer example, let's say we have 3 times the quantity x minus 6 plus 2 is greater than or equal to 5x minus 4. So, following these steps, first thing, if you have anything to distribute, you want to do that first. And I do here. I have the 3. So, we're going to distribute the 3. So, you have 3x minus 18. And then plus 2 is greater than or equal to 5x minus 4. Okay, next, we would want to combine like terms. Now, here's the thing, guys. On your equations quiz that you guys took like a week ago, I saw this so often. Students were like, hey, I can combine the negative 18 and 2 together, but they did like negative 18 minus 2 and called it a negative 20, okay? Remember, these are on the same side of the equal sign. When you combine a negative 18 and a positive 2, you get a negative 16, because they have different signs they cancel out, okay? So you have 3x minus 16 is greater than or equal to 5x minus 4. Okay, after we simplify both sides, I have x's on both sides, so to get them in the same place, we would subtract 3x from both sides. We'd have negative 16 is greater than or equal to, that would give me 2x minus 4. And now we have a two-step inequality, so we'd have 4. Negative 16 plus 4 gives me negative 12, which is greater than or equal to 2x. Divide both sides by 2, we have negative 6 is greater than or equal to x. Now, although today we're not graphing, I really think it's a good practice just to get in the habit, write that variable first. So x is less than or equal to negative 6 would probably be the best answer. That being said, if this were on a quiz or a test and you left it as negative 6 is greater than or equal to x, you wouldn't lose points. It means the same thing, but I would say the best practice would be to write the variable first. Okay, so that's like your normal answer, and honestly, that's probably about as hard as the problems get today, okay? Most of them are easier than that, okay? Now, like I mentioned, there are going to be these ones that don't necessarily end up with an answer, but they're going to look just a little bit different than whenever we had an equation. So if I have 6w plus 5 is greater than 2 times 3w plus 3. So similar steps. We want to distribute first, so that's 6w plus 5, that'll stay the same. But I need to distribute the 2. 2 times 3w will be 6w. 2 times 3 would be 6. After we distribute, we want to combine like terms. I can't combine anything together, but I do have variables on both sides. But when I subtract 6w from both sides, okay, kind of like an equation, equation, what happens? Yeah. Okay, they all cancel out. Now, with an equation, really, I said, okay, you need to look at what you're left with. And really, if I saw 5 and 6, I'd be like, no solution, which may not always necessarily be true with an inequality. Because this inequality isn't saying 5 equals 6, right? This inequality is saying 5 is greater than 6. You're still going to ask yourself the same thing. Is this true or false? Is 5 greater than 6? No. Okay, so, yeah, they're not the same number, but it doesn't matter that they're not the same number. It matters that 5 is not greater than 6. And since it's false, just like with an equation, that is a no solution answer. There's no number that works in that inequality. Okay? And then like this one, negative 4x plus 3 is less than or equal to negative 2 times the quantity x minus 5 minus 2x. So if we go through the same steps here, we would need to distribute on the left-hand side. There's nothing to distribute, so it would stay the same. On the right-hand side, be careful here, you would want to make sure you distribute a negative to both places. So that's going to be a negative 2x, and then negative 2 times a negative 5 would give me a positive 10, and then minus 2x. After we distribute, we want to combine like terms. There's nothing to combine on the left-hand side. On the right-hand side, I have these x's, so be very careful here. They're both on the right-hand side. So you just combine them together. You got a negative 2x and another negative 2x. When you combine those, you get a negative 4x. They're already on the same side, so you just combine them together. So it'd be negative 4x, and you still have that plus 10. Now you have x's on both sides. So if I add 4x to both sides, see how the same thing happens? Okay? And I see again that I've got 3 and 10, which I know is not the same number, but that's not what this inequality is telling me. This inequality is telling me that 3 is less than or equal to 10. Is 3 less than or equal to 10? And I always have students get confused with like the equal to, like, well, it's not equal to 10. I'm not saying it's 3 is less than and equal to 10. It's less than or equal to 10. Okay, so it could be 10 or it could be anything less than 10, right? And is 3 less than 10? Yeah. Since that's true, this is that all real number solution. Okay, similar to an equation, but you got to think just maybe a little bit harder because it's not just about whether it's the same number or not. Okay, all right, let's get this glued into page 27. This is section 3.4, multi-step inequalities. All right, so number 1. Okay, let's say we have 5f plus 7 is less than or equal to 22. So, I mean, you could go through all of those steps, right? Distribute, combine like terms, get your variables on the same side. You don't have to do any of those. This is just a simple 2-step equation. So, if I subtract 7 from both sides, we have 5f is less than or equal to 15. Divide by 5, we have f is less than or equal to 3. Now let's try another 2-step equation. Negative 5y minus 2 is less than 8. Same thing, distribute, combine like terms, get your variables on the same side, all of that stuff is done for you. This is a 2-step equation. So the first thing, to get rid of that minus 2, we would add 2 to both sides. Negative 5y is less than 10. Now to get rid of the negative 5, I'd have to divide both sides by a negative 5. Which means, yeah, I gotta flip the sign. Remember that from yesterday? So it's gonna be a greater than. So y is greater than negative 2. Now, one good thing about these multi-step equations what ends up happening, sometimes, not all of the time, okay? But we don't run into this as much in this section because a lot of these problems have variables on both sides. And whenever you have variables on both sides, as long as you move them the correct direction, the coefficient of your variable is going to be positive. So you don't have to end up dividing by negatives. It still will happen, but I don't think it happens quite as often as in the last section. Okay, let's try another one, number 3. 3 times the quantity k minus 5 plus 9k is greater than or equal to negative 3. So now this one, I do have something to distribute. Okay, I would distribute the 3. So we have 3k minus 15. And then we'd still have the plus 9k is greater than or equal to negative 3. Anytime after you distribute, you always want to combine like terms. Now notice the 3k and the 9k, but they're both on the left-hand side. So you just take 3k plus 9k, and you get 12k minus 15 is greater than or equal to negative 3. And now we have our two-step equation. So I'd add 15 to both sides. So we have 12k is greater than or equal to 12. And then divide by 12. We should have k is greater than or equal to 1. Okay, is this going okay? Yeah? Alright, number 4. 3m minus 4 is less than or equal to 6m plus 11. Alright, so nothing to distribute, no like terms to combine, but I have my variables on both sides. Now this is kind of what I was talking about, that I guess if you wanted to move it to the left, just kind of, you're used to having your variables on the left, you would end up with a negative coefficient. You'd have to end up flipping the sign. But what we learned whenever we did equations, I find it easier to move the smaller coefficient. So I'm going to subtract 3m from both sides. So we have negative 4 is less than or equal to, and that's going to give me a positive 3m plus 11. As long as that number is positive, you're not going to have to worry about flipping the sign. So that's kind of a nice thing about doing it that way as well. Now that we have our two-step equation, we can subtract 11 from both sides. So we have negative 15 is less than or equal to 3m. And then we could divide by 3. So we have negative 5 is less than or equal to m. And once again, best practice, just to get in the good habit of doing this, in case we do need to graph it, or if I maybe just said, hey, what's a solution? Okay? It's much easier to do that whenever you write the variable for, say, m is greater than or equal to negative 5. It's easier to think about numbers that are greater than or equal to negative 5 rather than thinking, well, negative 5 is less than or equal to all of these numbers. Okay, that's kind of confusing to me. Okay, what about negative 3 times w minus 3 is greater than or equal to 9 minus 3w. So first thing we distribute, be very careful anytime you're distributing a negative. Make sure you distribute that negative sign to both places. So this is going to be a negative 3w, but negative 3 times a negative 3 would be a positive 9. Is greater than or equal to 9 minus 3w. After we distribute, we want to combine like terms. Nothing to combine here, but I do have variables on both sides. So if I add 3w to both sides, hey, they cancel out. Now this time, right, if this were an equation, I'd be like, oh, 9 and 9, great. But just be really, really careful with inequalities, okay? Because with inequalities, even though they're the same number, sometimes it may mean it's a false solution. In this case, 9 is greater than or equal to 9. Is that true? And because it's an or, it is equal to, right? So this would be the all real numbers. Now, if this was just a greater than, not a greater than or equal to, That would change my answer, wouldn't it? Because 9 is not greater than 9. Just that one simple difference there would make that a no solution answer instead. Okay, 6m minus 5 is greater than 7m plus 7 minus m. Okay, now this one I have nothing to distribute, but I do have some like terms to combine. Not on the left, that 6m minus 5 will stay the same, but on the right, I have a 7m and a minus m. Remember, they're on the same side. So all you do is take 7m and you take away an m. So 7m taking away an m gives you a 6m plus 7. Okay, can't solve for m, 5 m's on both sides, so we would subtract 6m from both sides. But just like the last problem, okay, my variables all cancel out, and I get negative 5 is greater than 7. You have to really think and ask yourself, is negative 5 greater than 7? No. No, because having negative 5 is negative, first of all. Right, so you'd say no, that's no solution. That one's not going to work. Okay, a couple more. Okay, number 7, negative 3 times the quantity j plus 3 plus 9j is less than negative 15. Okay, what's my first step here? Distribute. Make sure you distribute a negative 3 both places. So it'd be negative 3j. Negative 3 times 3 would give me a negative 9. And then plus 9j is less than negative 15. After we distribute, what should we do? Combine like terms. Good. And these are on the same side. So negative 3j plus 9j gives me 6j. Minus 9 is less than negative 15. What next? Add 9 to both sides. So 6j is less than negative 6. And then divide by 6. Now, it is negative 6 divided by 6. Should I flip the sign here? No, you're right. Why? It's a negative 6. Yeah, you guys are both right. Yeah, you said it differently, but yeah, this is the 6 that matters, right? This is the 6 that would have to be negative. It doesn't matter if that's negative or not, right? You guys are very right. So it would say it would be a negative 1. And you keep this side the same. That's a negative 1. It does not look like a negative 1, but that's what it is. Okay? All right, last one. Number 8. 2 times the quantity n minus 8 is less than 16 plus 2n. Okay, well first, distribute. So we have 2n minus 16 is less than 16 plus 2n. There's nothing to combine. So what next? Good. Yeah, I've got my n's on both sides, right? So I need to subtract 2n from both sides. Really careful here. Okay, the n's cancel out. See that? Make sure you don't cancel out too much, right? Because the 2n cancels out, but that negative does not. So it's negative 16 is less than 16. Is negative 16 less than 16? Yes. So which answer is this? All real numbers. Very good.